Good morning. This is Dr. Turner for Integrated Math 1. Today we're going to be getting into 9.4. 9.4 and 9.5 are both going to be looking at triangle centers. So in 9.4 we're going to be looking at incenter and circumcenter. And then in 9.5 we're going to be looking at your centroid and orthocenter. So let's go ahead and just jump right into it. Now for 9.4 and 9.5, it's really important that you guys take some good notes. If we were in person, I would be letting you use your notes anyways, but a lot of this is going to look kind of confusing, for lack of a better term. Some of it is going to be confusing because it's going to sort of all bleed together. You're going to have a lot of very similar looking symbols, and it's very easy to get these four types of triangle centers confused. So particularly when we're looking at, let's say, a scalene triangle, the question becomes, well, how do you know what the center of a triangle is, right? Is it the same distance from all the angles? Is it the same distance from all the sides? And so because of this, or lack of a, quote unquote, official center of the center of a triangle, we have a couple ways that we can obtain a point that we will refer to as the center of our triangle. The first of which is formed by drawing perpendicular bisectors. Now, we've covered this before in first semester and also in fundamentals if you took that class. But perpendicular bisectors are, of course, lines that are perpendicular, but they're also bisecting a side. Because we're talking about the triangle, a bisector is then going to cut the line segment in half. So let's say we had triangle here ABC. A perpendicular bisector is going to be a line that is not only cutting a side in half, but it's also forming a right angle. Now, I'm doing this on the computer, so it's not going to be completely accurate, so bear with me, but the idea is that you're forming a 90-degree angle on each side, and it's cutting each side in half. So for instance here, we'll call this middle point M. AM and CM would be the same length. And so you're going to do that for all three sides. So I'm going to draw a perpendicular bisector that is cutting AB in half at a 90-degree angle. Again, forming two equal parts, so we'll call that N. So AM and BN are the same. And then lastly, we'll cut BC in half with a perpendicular bisector. And switch it up a little bit, about there. Again, bear with me because I'm doing this all on the computer and some of it's a little auto-tuned. But in this case, we'll call this P, BP.
I don't know that one.
And CP would be equidistant as well. So where those three lines intersect is one way of thinking of the triangle center. The triangle center that's formed by drawing three perpendicular bisectors, we refer to that as the circumcenter. Circumcenter is kind of tricky in that with a circumcenter, you can end up with a point that is either inside, outside, or on the triangle. If you're looking at an acute triangle, like ABC is here, then your circumcenter is going to be inside the triangle. However, if you're looking at let's say, right triangle, and again, it doesn't matter how it's oriented, but if you're looking at a right triangle, then when you go to draw the perpendicular bisectors, you're going to end up with a point that is on the triangle. Again, bear with me because I'm doing this on the computer and some of it's not entirely accurate, but if you were cutting each of these line segments in half, each of the sides in half, rather, no, that's okay. If we're cutting each of the angles, each of the sides in half, and we're drawing perpendicular lines, then again, if we were doing this, a little more accurately, then you end up with a point that is on the triangle. And this is again formed by drawing all the perpendicular bisectors. So these two segments would be the same, these two segments would be the same, and these two segments would be the same. Each of these is formed by drawing a perpendicular bisector, so each of these lines that I'm drawing through would be meeting at a 90-degree angle. So with a right triangle, you end up with a circumcenter that is on the triangle. With an acute, you end up with a circumcenter that is inside the triangle. And then if you look at an obtuse triangle, then you'll end up with a point that is outside the triangle, which may be a little bit confusing because we're talking about a triangle center. So how could the center of the triangle be outside of the triangle itself? But this is just based on the definition that we're giving to it, right? So again, this point is being formed by taking the perpendicular bisectors of the three sides, more or less, okay? Right triangle here, or right angle there rather, and then we have a point here, and then we have a line segment here. So drawing all three of those perpendicular bisectors, roughly, okay, you end up with a point that is outside the circle. So all three of those are example of circumcenters. Again, circumcenters are formed by drawing the perpendicular bisectors for the three sides. And wherever those three new lines meet, that is your circumcenter. That is one way of thinking of the center of a triangle. The other way we can look at the center of a triangle is what's known as the incenter. So the circumcenter, we cut all the sides in half, specifically at a right angle. The incenter we're going to form by drawing the angle bisectors. Angle bisectors, of course, are line segments that are dividing the angle in half. So no matter what type of angle we have, it's cutting the angle in half, and it could be acute or it could be a right angle. So again, it doesn't matter what type of triangle it is, the same is going to be true. So let's say I have, for instance, an acute triangle, and then I am drawing all of the angle bisectors here. So by drawing those three angle bisectors, again, we're roughly, because I'm doing this on the computer, and it, like you can see here, it likes to be a little bit fidgety, but we draw the angle bisectors, and if we were doing this on paper, we'd be using a compass to construct each of these, but dividing each of the angles in half, roughly, again, we end up with a point of concurrency, as it's called, and that's formed by cutting this angle in half, cutting this angle in half, cutting this angle in half. So 9.4, that is your assignment. Be able to distinguish between the circumcenter and the incenter, be able to define in your own words or give an example of circumcenter and incenter, and also what form those two, which are your perpendicular bisectors and your angle bisectors. The other thing to note about these two types of triangle concurrency specifically is that when you draw the circumcenter, okay, you end up with a point that is equidistant from your three vertices. So let's call this center point O. So if I were to draw a line segment between AO or BO or CO, those line segments would all be the same. So that's just, kind of a unique observation, but by dividing all the sides in half and drawing the line where they intersect, the point is equidistant from all three vertices. Similarly, if I'm looking at incenter, I'm getting a point that is equidistant. I'm cutting all the angles in half, but that point is equidistant from all three sides. So if I drew the shortest line possible between that point and the three sides, the incenter is a point equidistant from the three sides. So a circumcenter, you cut the sides in half, you get a point that's the same distance to all the angles. Incenter, you cut all the angles in half, you end up with a point that's equidistant from the three sides. That's it for 9.4. If you have any questions, please reach out to me. Otherwise, have a good day, and I will talk to you soon. Bye.